So hopefully you've got something like your beginning looks something like this. Having a look, 3 sine x minus 4 cos x equals minus 2. What is it about that that's going to make us think auxiliary angle anyway? Well, this is a simple sine x. This is a simple cos x. And besides that, the more exposure we have, the more used to we become of recognizing this situation. So, yeah, I think that it won't take very long and you will look at that and go, oh yes, that's going to be I'm going to use the auxiliary method there. So then it's a matter of matching. So hopefully you can see it is the sine angle identity. But this time it's the subtraction of the angles. So it was from r sine a minus b, or I'll read it from here, then gives r sine a cos b and r cos a sine b. So the match actually becomes, so it's sort of like we ignore that for a minute and we'll ignore that. And we're just going to take the 3 and match it up with everything else except the sine, which leaves us with that 3 is actually r cos b, or r cos b is 3. Now, for me to get an understanding in a right angle triangle of what cos b is doing, I need to get cos b. Cos of b is adjacent over the hypotenuse. I've drawn my right angle triangle. Doesn't matter where I put b. These numbers are not familiar to me, 3 and 4. Not in terms of an exact triangle. Now I'm going to go to use my calculator here. So I've just put b down here. I am happy with this as a triangle because I know that r is automatically 5, and we get that from knowing our Pythagorean triads, 3, 4, 5. Sine of r sine b, we got doing the similar thing. It's like we cross out that because that's what we had. All we've got left is the 4, and all we have left in the pattern here is r sine b equal to the 4. Sine b is r on 4, and so we've got this situation. R is very easy to evaluate. We don't really need to use Pythagoras if we know our Pythagorean triads. R is equal to 5, and we can then say either one of these that, for example, so we've got R. We've got our value for R. That was pretty easy to find. Remembering that we have to find the value of R, we have to find the value of the auxiliary angle, which we've named B here. You could have named it Y, that's fine. You could have named it theta. You can give it whatever name you like. So then our next step is to find the value of that auxiliary angle. So what do we know from here? We know 2 things, and we're going to use either one. But I've just chosen that sine B is 4 on 5. Sine of B is 4 on 5. How do we get B? We take the sine inverse. Now this is junior school stuff. B is the sine inverse of 4 on 5. Let's go to the calculator. Make sure your calculator is in radians. Sine inverse of 4 on 5 gives me 0.927. I'm going to say that, yeah, maybe I'll go that far. 3 decimal places. So B is equal to 0.927. I think that's what I said. So now instead of writing my left hand, or the left-hand side of the equation in this form, I can now replace all of that with this. So my equation now looks like 5 sine x minus my b value, which was that, my auxiliary angle, is equal to minus 2. That's a nice simple equation. You've solved those back probably 2 chapters ago. What do? We'll divide both sides by 5 and then take sine inverse. And So dividing both sides by 5, we've got take the sine inverse, looks like that, and so we've got just the bracket left here. I'm going to take the negative 0.95 to the other side with the sine inverse, go to the calculator, got that typed into the calculator, minus 2.5, and you can see that the angle you would have in radians, let's call that x is equal to 0.52 radians, 52, yeah, to 2 dp. I'm sure you'll let me know if I've made a mistake anyway through that. And I think I will go through the rest of the examples with you in class. So if you're feeling like you'd like to go through them prior to that, please do so. And then you could begin some of the questions out of the textbook.